Okay, then reflection we covered in detail earlier in the year, so I'm going to go through this fairly quickly. This really is just a revision to remind you of what we did earlier in the year. You should all have been through it. You've done it in assignments, and you should all have done this in your examples in the exercises as well. So this should really just be a reminder of what has gone in the past and help you with revision for the exam. Right, chapter 12, reflection. Reflection is a self-examination on an object's members. It provides information about the properties and methods of an object. And the advantage of this is that you can access that information without actually knowing anything about an object. So that is the main advantage of reflection. It allows you to access the properties and methods of an object without actually knowing or necessarily knowing anything about that object, which is quite useful in various situations. Right, reflection involves the use of what is known as a meta-object, and that is an object that describes the structure of another object. So a meta-object is quite an important concept when dealing with reflection. And then in QT, we have a class, which is very important. It would be very difficult to implement reflection without using a QVariant. And a QVariant is basically, acts like what is known as a union for most QT data types. Just as a reminder, a union is a special C++ class type that can hold only one of its non-static data members at a time. So union generally has quite a few different types of data members defined, but it can only hold one of those at a time. And that is what QVariant does. It is an object that holds a single value of a single type at a time. And those types can be multi-valued. They can be lists like QString list, for example. So QVariant is basically a variable that can store pretty much any data type. It has definitions for all the data types in QT. It can accept any of them, but it can only accept one of them at a time. Once you've assigned a particular value or data type to a QVariant, it cannot accept another data type. So it can store basically any data type, but only one at a time. And that is pretty much what a union is in classic C++. So QVariant is the QT equivalent of a union for practical purposes. Then the other thing that's necessary for reflection in QT is QObject. QVariant and QObject are largely what makes reflection possible. QObject is the base class of all QT objects. It has some useful methods. The meta-object method, that returns a pointer to the object's meta-object. As we said before, you need the meta-object to get information about the structure of your object. It has a set property method, which allows you to set both fixed and dynamic properties. As far as setting properties are concerned, there's no difference between fixed and dynamic properties. They both use the set property method, which sets a name and value pair. Then QObject has a property method, which accepts a property name. Returns the property name, and that returns it as a QVariant of the property value. Then you have dynamic property names, a method which returns a QList of dynamic property names. Okay, you should have dealt with all of these before, so we're not going to spend too much time on them. Then declaring fixed properties. In QT, you need to use the QProperty macro in a class that inherits QObject. Just remember to use the QProperty system. The class must inherit QObject, and you've also got to include the QObject macro. Right, the general form is QProperty, then the type, like QString, for example, then the name of your property, then the read keyword, and then your getter function. And note, when you use it in your property declaration, there's no brackets following that method. It's just the actual name. Then the right keyword is optional, and then your setter function name. Note that invariably you would use both the read and write keywords. There's actually very little practical value in a property that you can't write. There is apparently a rather obscure use for it, but generally you would include read and write functionality. Okay, this is an example of code to declare your fixed properties. As I said earlier, you must inherit QObject, you must include the QObject macro, and then you include the Q property macros to define each property. And notice that this Q property is a Qt macro. It's not a C++ statement, so there's no semicolons at the end of the line. In this middle one, for example, we declare the type as a Q string, and we give it a name of ID. Then we use the read keyword. We reference the getter called getID. This is referencing this public method here, which is a getter. And notice it's only the actual name. There's no brackets, there's no constant or return type or anything like it. It just references the name. Then we have the right keyword, and that references the setter method, setID, which is this one here. Again, it's just the actual name, no brackets or anything else. So that is how you declare your fixed properties. Normally, you would just include the read and write functionality. There might be occasions where you want to include the notify keyword, and that references a signal. In this case, a signal named phone changed. You can get your property to emit a signal at the appropriate time if you include this notify keyword in your property declaration. And that references a signal. So declaring fixed properties, I think, is simple and straightforward. It should be fairly easy marks in the exam, and hopefully you've been through the exercises and assignments and be able to do all this. Again, this is something that comes up in every exam, so you must know how to do this. You must know how to set fixed properties, and we'll look now briefly at retrieving properties. Okay, an example of setting fixed properties, you can use the setters, set ID in this case, or set phone, or you can use the set property method. There's no difference in usability between using the setters that you defined or by using the specific property-related set property method. Personally, I prefer using the set property method because it's then explicitly clear that you are intending to set a fixed property, whereas if you use the normal setter, it's not clear that you are actually trying to use fixed properties. But both are acceptable, both work, and both do pretty much the same thing. Note that QObject has a default property, which is known as object name. So for any object derived from QObject, there is one fixed property already defined, and you can call the setObject method to set that. It's important to remember this when you're retrieving your fixed properties, because you will always find that there is one more property than what you expected. There will always be one more property defined than the number of properties that you define yourself. So QObject already has one default property set. Right, then to read your fixed properties, you need to declare a meta object, and you use the meta object method of QObject to retrieve that meta object. Right, you need to use that meta object to recover information about your object. You can then determine how many properties the object has by using the property count method of meta object. And bear in mind that'll always be one more than you would normally expect. You then use a normal loop to loop through the properties. You use your property method of meta object to retrieve a Q meta property. That meta property then contains more detailed information about your property. You then use the meta property name method that retrieves the name as a constant character, and then you use that name along with the property method of your Q object with the property name as an argument, and that retrieves your property value as a QVariant. You can then use that name and that value as you see fit in this. Here I just streamed it out, and I just want to point something out that we'll look at over the page again. Here I've just assumed that it can be converted to a string. Bear in mind you cannot just assume that, because your value could be any type that QVariant supports, and you should actually do more sophisticated checks on what the type is of that property value. Don't just use it and assume it's going to be a string or an integer or something. You must actually check on that. Okay, and then just a bit of a comparison about fixed properties and dynamic properties. Fixed properties are defined at compile time. Your fixed properties are stored in a Q meta object, and all objects of a class have the same meta object. Notice something that quite often confuses. They have the same properties. It does not mean that those properties have the same values. So all your objects in a class will have the same fixed properties, but those properties can all have their own values. So don't confuse those two and think that because they have the same properties that they all have the same value. They don't. They have basically the same property names, if you want to put it differently. And each of those can have their own value. Then dynamic properties are handled at runtime as opposed to compile time for fixed properties. And your dynamic properties are added to QObject and not to Q meta object. So that's another difference between them. And your dynamic properties are specific to each object. Objects all have the same meta properties, but different dynamic properties. So you define dynamic properties object by object, and you define fixed properties class by class. So note those differences between the two. You use the set property method to set dynamic properties, and that is exactly the same for fixed properties. So there's no difference in setting your properties. It all depends. If you have defined a fixed property, then it'll be set as a fixed property. If you haven't got a fixed property set with that name, then it'll become a dynamic property. And just be careful of how set property it returns returns these values, and it behaves differently if the name exists and the value is compatible. Then the value is stored and returns true. If the value is not compatible, the property is not changed and returns false. But if the name does not exist, the new property is added to QObject, in other words, as a dynamic property, but it then returns false. So you get false returned in two different cases, which may provide you with misleading information, because in one case the property is added or changed, in the other case the property is not changed. But you get false in both cases. So be careful of that. Okay, then reading dynamic properties. You use the dynamic property names a method of QObject. Notice that that returns a Q list of Q byte array, which is a slight complication, but it's quite easy to overcome. Generally then, to retrieve your dynamic properties, you just use a for each loop, and you recover the name from your list of property names that you set up, or that you retrieve from this dynamic property names method. You can then retrieve the name directly. Remember that the name, DP name, as I've called it there for dynamic property, is a Q byte array. Q string can take a Q byte array as an argument. So you can convert your Q byte array to Q string just by putting it into the Q string constructor. That gives you the name directly. And then you can also use that property name as an argument to the property method. And that gives you your value. And again, this is a very simplistic example. Don't just assume that it can be converted to Q string. But remember, this property value is actually returned as a QVariant, and you need to convert it to the appropriate type. Here's an example of checking for your property type. You can use the type name method to check what its type is. So you can check to see if it's a Q string list, or if it's a Q string, or if it's an integer or whatever, and then deal with it. But don't just assume that your answer or the type is going to be a Q string list, for example. You must actually check that. Otherwise, you will run into problems. There is an alternative approach. QVariant has a can convert method. In other words, you can check to see if it can convert to a Q string or can convert to integer, and so on. So that is a different way of being able to check the property type. But in general, do not just assume it can be converted to a string or something else. You must always check by either explicitly checking the type name, or by using something like the can convert method to check that it is convertible before you actually try and do it. This is quite an important aspect when dealing with QVariants. Remember, QVariant can be almost any type. Always check that it can be converted to the type that you want to actually use. Don't just assume that that conversion will happen. Then another aspect of dynamic and fixed properties, using the set property method, your property names are case sensitive. If you define a fixed property, as we did at the beginning, using lowercase, and you use set property, that will set or change your fixed property. If you inadvertently call your set property method using capital letters, and you define your fixed property with lowercase, you won't set your fixed property. You will actually add a new dynamic property. So just be very careful with that. Your property names are case sensitive. Just make sure that you are very careful about that, and that you don't make the mistake of actually adding a new dynamic property when you actually thinking that you are setting a fixed property. It's very easy to muddle those two up, because you've used the same method for both fixed and dynamic properties. And if you're not careful with your case sensitivity, you could end up doing something quite unexpected. Then also at the beginning, I said when you define your fixed properties, the right accessor is optional. So the question has arisen, what happens if you define a fixed property that can only read, and then you actually call a set property method to try and write to it? What actually happens is nothing, and it doesn't return an error. So just be careful of that. If you've defined your fixed properties and you don't define a right accessor, but you then call the set property method to set your property, you'll discover that you haven't actually set a property, and nothing will actually happen, but it doesn't return any error. So there's no way of actually knowing about that. So just be careful of that. If you need a right accessor, make sure you specify it when defining the property. Otherwise, you will have a hidden bug in your program, and that kind of thing is very difficult to find. Okay, so you just need to be very clear on the differences between fixed and dynamic properties. There's no real difference in setting them, but just make sure you know that you're actually setting a fixed property or dynamic property. And then the only real difference is retrieving your fixed and dynamic properties. There's different methods and different loop type that you use. Just make sure you're clear on those. You will invariably get a question in an exam that requires you to use properties. Just make sure that you can set and particularly retrieve them, because the retrieving is the slightly more complicated part. Setting them is straightforward. So just make sure you know and are very clear on how to retrieve both fixed and dynamic properties. Otherwise, that should be fairly easy marks in the exam. Okay, unfortunately, there's quite a bit to do, so we're going to go on for a while. It's quite a bit to take in, but as I said,